Cool. So this is sort of a part one talk on OTP in Elixir. Before we get started, I just want to introduce myself a little bit. My name is Christian Lorenzo. I work at Role Model Software. A couple other guys that are here tonight. I sort of got interested in Elixir in 2014, early 2014, and just sort of did some side projects, a little bit of production, nothing too crazy. So I really just want to get you guys started into thinking about OTP in Elixir instead of just functions. So let's get started. So what is OTP? OTP actually stands for Open Telecom Platform, but it is not for just telephones. It was just telephones in the 90s. If you ever get a chance, the YouTube movie Erlang, the movie, is pretty interesting to watch. It was produced in 1990. It's pretty interesting. So I want to go through a couple quotes just to get started of introducing what OTP is. So Joe Armstrong is the primary creator of Erlang. He says OTP is an application operating system and a set of libraries and procedures used for building large-scale, fault-tolerant, and distributed applications. So this is not for just running scripts and your typical application. This is for producing applications that last for years and are able to handle system failures at different levels in the stack. Also, Francesco Cesarini, he started as an intern at Ericsson and started Erlang Solutions in 1999. And Steve Vinosky, in their book, describe OTP as a domain-independent set of frameworks, principles, and patterns that guide and support the structure, design, implementation, and deployment of Erlang systems. So in other words, this is a whole structure. So there's three primary components of OTP. So you have Erlang, which is the syntax and semantics, includes virtual machine, Beam. That's going to give your core features, including like your nodes, your schedulers, processes across your nodes. All of that is handled by this component of OTP. You also have your tools and libraries. This would include everything from ETS, Erlang term storage, to the observer module. Amnesia is another one. We won't be talking about that as much tonight. I want to primarily go over the system design principles, like I said, to sort of give you a starting point for your own applications. So system design and principles includes the generic behaviors of Erlang. So instead of jumping into GenServers, which is probably what you've heard of when we talk about OTP as the basic building block, I want to go a little bit before that and talk about the Erlang process. And I don't mean how to build software, but the process itself. So in Erlang, a process is not equivalent to an OS process. It's much more lightweight. In fact, the Beam schedulers it creates an instance of schedulers across each core in the machine, and then as you create processes, it will distribute across those schedulers. And so like I said, they're very lightweight. You can create many thousands of them. I think the default limit is like 262,000 as the default Beam configuration, but you can change that. Also, processes use a mailbox system. So it's a share nothing approach. There's not like state that you're going to have that's going to be both mutated by two processes. So they have, like I said, it's a mailbox approach of you send messages. So your messages that are being sent to your processes are deep copied and then pattern matched, often using tuples and atoms and all that. So the Erlang process is also similar to a client-server relationship, and I don't mean like a network, HTTP sort of connection, but much more of a you're requesting something from this. It's not like the object-oriented technique of just spawning off a process to do a job and then coming back and you're done. It's more of a much longer living sort of thing. So in this case, it could be a many-to-one for your client-server, one-to-one, or one-to-many. And these processes can run on the same machine, on a different node on the same machine, or a completely separate machine in a different node. So the basic process architecture is a start, initialize, loop, and terminate sort of thing. So you'll spawn your process, maybe you'll link it to your current process so you can manage when it dies, you can get events and handles into that. You'll initialize your state, which is immutable, but we'll get to that. And then you'll loop around receiving messages, pattern matching on them, you'll evaluate them, maybe you'll respond, and then you'll loop again. So it's this infinite loop, and we'll get into this later. And then you'll have a termination, either abnormally or normal termination, and that's sort of the life process of a process. So I want to start out using an example of a URL shortener. This is not going to be anything fancy. I just wanted an example where we don't have to worry about the logic, but more of the architecting it with processes. So this is how you would use a basic process. There's no GenServers. You're just using 3 primary constructs. You're spawning of your process. You're sending messages and receiving. So in this case, I just have 2 simple tests, shortening URL and finding URL. So the message here is being sent as the shorten with the whole tuple thing. And self is a reference to yourself, your process ID, so that you can respond with messages. So I want to jump and do that as a live demo real quick. Hopefully this will work. And if you have any questions, please let me know. All right, so I've got the test up here. If we go in. So we'll start out with this module. Is that big enough for you guys to see? I'll make it bigger? Bigger? Better? A little more? Okay. All right, so by convention, we'll use a start link call, and that's because of GenServers, but we'll get to that later. So this start link is going to have our process ID. So we're going to use a kernel function called spawn link, and we're going to give it the current module, the function to call by name, and then a list of arguments to pass into that. So for this example, as a URL shortener, we're just going to use a simple map where you have the key being the shortened representation and the value being the URL to redirect to. So in this case, we would initialize our state with an empty map. So if I run this, we'll make sure it's okay. All right, so no function loop. So I'll go ahead and define that. So this is where we'll accept that state, which will initially be our empty map. So this is where we use the receive block to pattern match on the messages that were being sent. So the first one here would be our shorten, process ID, the shortened representation, and the URL. Then the other message we're receiving is URL, they're on line 16, this one, another process ID, and a shortened representation. So each of these calls, like I said, it loops. So at the end of these calls, you always have to reference back to the function, like so. So Erlang and Elixir, like some other languages, use tail call optimization so that it doesn't add another frame to the stack when you do a call, as long as it's the last call in your function. So this way we maintain immutable state and we can keep track of things. So in this case, we will actually just update this. Let's see, state. So just updating that, and that's the new state that will be passed in for the next iteration. And here, actually when we respond here, so this receives an OK, just to acknowledge the message. So here we can send to that message. And here we would send the result. And fetch in this case will return either error or OK in the value. So if you run this again, hopefully they'll pass. All right, so any questions about that so far? Does that make sense? So we're spawning a process, we're looping it around, receiving messages, sending back things.
What's the return from spawn link? Is it the PID?
Yes. Mm-hmm. Yeah, so that gets passed in here to the test. All right, so in its current state, it's very nice, it's simple, easy to use, not much code. We haven't done any generic behaviors or anything, so we are missing a couple of things. GenServer is very nice. It handles edge cases such as deadlocks, synchronous calls between processes, timeouts, all that sort of thing. That's already handled for you. Also, I remember I said that there's a mailbox system for communicating between processes. We pattern matched on 2 different responses. If it doesn't match that, it just goes and fills up the mailbox. So I could send a ton of messages and this will fill up memory infinitely. So we obviously want to avoid that, and GenServers will take care of that for us as well. Also, it cannot be referred to as an alias in its current state. So usually you have a process ID, pass that binding around, and you can use that, but you can actually refer to a process ID by an atom, usually by the module name, which is an atom, or by some other reference to it. So we'll sort of refactor this as a next step. So to do that, we want to talk about GenServer and how it works to be able to refactor this. So in OTP, there are a number of generic behaviors, including the infamous GenServer, but there's also a number of others. So FSM, finite state machines. If you didn't do a CS degree, that means managing between states and transitions between them. Think of like a vending machine. You don't want to accept payment before you selected a drink, all of that sort of thing. It's managing that only certain actions can take place in certain states. Gen event, which is very nice for logging, that sort of thing. It's essentially for sending out to multiple handlers where you don't care about a response, maybe email exceptions, that sort of thing. There's also Gen TCP, so built-in functionality in Erlang for TCP connections and sockets, which I will be using at the end in a demo, but I won't talk about that much tonight. And then the other part that's often mentioned is supervisors. Supervisors will handle restarts of workers, different strategies of if one worker fails, do we restart the whole bunch? Do we just let it die? What happens? So I won't talk about that tonight either. So this is just going to be primarily focusing on the GenServer. But I will at the end, like I said, give a demo sort of putting all the pieces together. So the GenServer is a client-server abstraction, as I mentioned, in terms of the process relationships. And it has its own functions, and then it has callbacks. So to sort of visually draw this out here, so you have your custom module, and you start that out with a start link call, which will delegate off to your GenServer, which comes back, it spawns your process, you initialize your state. So it's just formalizing what we just wrote. So instead of having a function just looping over, it handles all of that. And then you can decide whether you're making synchronous calls into it or asynchronous calls. And then you have the whole termination process. So it's the same process, like I said, in the first drawing of you start, initialize, loop, and then terminate. It's just in a little bit fancier model, and it handles a lot of edge cases. So rethinking about our Erlang process as a GenServer, I'm going to sort of step through this. Like I said, if there's any questions, please stop me. So here I've added a new test here, but you'll notice that there's not as many fancy tuples of 5 elements or 6 elements or whatever. They're actual function calls. The only thing that we're tracking in this case is the process ID to pass around. So it's typical to pass that as the first argument and then whatever message you're sending to it. And then underneath it uses GenServer behaviors. So it should look pretty similar in terms of the results. So we can ask it for a URL and it's going to return OK in the value, or if it doesn't exist, it's an error, or added a duplicate alias sort of thing. So I want to step through this as well. All right, so here is the test. Let's see if I can make this a little bigger. So here we'll start out with the module. So here we're going to inject behavior with GenServer, and this is specific to Elixir. Some of the other generic behaviors, like I think GenTCP and GenEvent, don't have a specific Elixir module, so you have to drop down to Erlang to run that. So we'll go ahead and start here again, the start link, and I'm just going to include some options here, and I'll explain what that means in just a second. So here we will just pass in the state itself, and then we'll pass in options. So this is where you could register your process ID by name by doing something like this. So this is a list of arguments, that's why there's 2 arrays. So this would be name, and it's common to use that sort of syntax. So then actually when you're using the observer tool, if you've ever seen it, you can actually see your different processes live, and so it'll be named that rather than some obscure number. But anyways, for now, we'll just pass in the options. So then I said you have another callback, init, that takes the state, and since we're not doing any fancy setup, we'll just pass it through. So the functions here, we have shorten, you'll see on the test there. So I'm going to take a process ID, URL, short. So this is where we decide, do we want this to be an asynchronous call or a synchronous call? I'm going to use just synchronous calls in this case because we want a direct response from it. But it is still running in a separate process. So this is call, process ID, and this is where we still have a little bit of the tuples. And then our other one is URL. Let's make sure. So those are the actual functions. Now we'll also have to implement the callbacks, handle call, to actually give a response to these. So these are going to be executed, of course, in your current process, whoever's calling it. But they do a direct, delegation off to the GenServer, which will go to the spawned off process. So these are going to be our callbacks. So this is where we receive the message. And you can also get a reference to the calling process ID and then your current state. So as before, we are going to have to return the state, and there's some special tuple responses of whether you want to reply or not reply, what you want that response to be. But it's generally in the format of reply, whatever the value is you want to respond, and then your new state. And you'll notice that looks pretty familiar from before. So let's make sure that we're on the right track here. Okay, so there's nothing matching this URL, so we'll implement that as well. So this is when we'll ask for that shortened URL, or the full URL from the shortened one. And here, we will reply with that map.fetch. So hopefully you should sort of be seeing how this is similar to the other, but slightly different. Let's see. So that shouldn't change the state at all. So if we run that now, I added a new test here just to sort of add a little bit more logic in here. So if there's a duplicate alias, we'll go ahead and reject that. So this just needs to be refactored to be shortened. And so if there's nothing there, then we'll go ahead and accept that. And if there is, then we'll reply with current state. So it's very common, if you haven't seen the pattern before, of using these tuples of OK, error, all that stuff. This special with keyword word, if you've heard of that, that was introduced in pretty recently, I think it's 1.2. I can't remember exactly, allows you to sort of sequence through there and accept the first one, return the first one that doesn't pattern match. So that's sort of that. Any questions about this so far? I feel like there's questions, but...
Well, I think we're kind of lost. So you start the process on the left, and then you start the process on the right, and then the right at setup calls and does the initialization of the link?
No, sorry. The one on the right is the test.
Okay.
So this is usage of this module.
Right.
So
you start the module on the left first, because it's going to wait for requests, correct?
this is the only module we're testing. So it's going to call start link, and it delegates off to GenServer to do our spawn link like we did before. And then it calls init. Does that make sense, or?
Not really. I mean, the process on the left is going to sit there and wait for requests, and you're not going to do any requests until you start running those tests, correct?
Correct.
Correct.
Right.
Okay.
Yes. Yes, it is waiting. Just sort of like the loop from before. It's just waiting. That receive block, it blocks your current process. So it's waiting for a message.
And then, you know, in your setup on the right, is the start link is it's special, but that's you're calling the function start link. You're correct on the right?
Correct. It's only convention.
Okay.
It's because the GenServer function is called start link.
And then I don't see how you collect a tuple if the start link didn't obtain. So you call start link and you're catching a PID and an OK, but what if the PID didn't come back?
It would return error. Yes.
It would blow up?
Yes,
Okay.
it wouldn't match. Correct. Yeah.
Okay.
Yeah, great, good questions.
Thank you.
Any other questions so far? Yes.
When is the, so you have the def init state, when is that called during this whole process?
So after the start link, the GenServer spawns the process and then calls init.
Okay.
So that's now on the separate process.
So that when you pass in that empty hash, that goes in, and
Yes.
then it will call
Directly
a
in here.
and pass that directly into there.
Right,
Got it.
right, yep. So in other words, like if your initialization takes too long, it'll time out. So it has behavior like that to handle all sorts of things.
When would you use a init for setting up initial state versus just passing it in start link? Is there a difference?
No, the init is the callback. So you wouldn't directly call a init. Maybe I'm not understanding.
I don't
GenServers
Yes.
is calling a net, right?
Correct. You call the start link, and the start link spawns the process and then calls the init.
So you could move the init down below the callbacks comment. Would that be clear? Is that what you're saying, right?
Yes, that would be great. Yes, that is a
That's one of the
callback.
things that the GenServer
Correct.
calling in.
Yes. Very.
Uh,
Yeah, that makes things a little bit clearer.
and then is handle call also a special GenServer call?
Yes. So handle call corresponds directly to GenServer.call. And then there's the same thing with cast. Cast just means that it's asynchronous. So you can look at the documentation of what type of
Oh,
return
I see it
values.
now. And then handle call came
Right.
in shortened, so they're going to call
Yes.
it shortened version.
It was a bit confusing when I first sort of looked at this, of these functions, and they're like, oh yeah, this is using GenServer, and it was hard to tell how that whole thing goes through. I can post that drawing that I made of the sort of callbacks back and forth.
Oh yeah, I'll talk to you afterwards. I'd love to get some help like this. So.
Yes.
Just to back up a step and make sure I've got the right orientation here, the point here is to be able to use OTP, you want to use things like GenServer to structure.
Correct.
So you can take advantage of that whole framework and everything
Yes.
it gives you.
Yeah, so the idea is to structure your application in terms of processes. And it's almost like objects in the sense that you're passing messages to them, and there's not a sharing state between them. You don't mess with the internals of
This
other
was that
objects.
same article I did about how Elixir is the most object-oriented language.
Yeah, I don't know about most object-oriented, but yes, it is similar in that sense.
So right now, do you just have one process going because you're synchronous? 'Cause
Well, there's the test process that's running, and then there's the separate process here. So there's two.
But you're not, like, let's say those 3 tests ran quickly, you're not spawning then 3 instances of the thing on the left at this point in time. You're going
Actually, you are. Yes,
You are, okay.
yes. Each test it does. So if the tests run asynchronously, it'll for each process there it'll spawn a new one because this is a setup for each one.
Okay. So are you running synchronously in this case or asynchronously?
I think I'm running synchronously. I think you have to do what is it, async?
Yeah,
True.
which I think means that it'll spawn a process
For
the
each
test
test.
in this file.
Right. Yeah. So if we run
The
that,
file is like a separate
Yeah.
thing.
you're not gonna be able to see a difference, of course, but it's faster.
So you haven't talked much about what this gives us. Is that
Yes,
Is that
I will
next?
continue
Okay.
on. Yeah. So this is an improvement. Obviously, we do handle some edge cases, and we can now alias it by an atom, sort of a minor thing. But primarily the edge cases and sort of structuring things nicely is very helpful. Unfortunately, sort of getting to your question of structuring your application, this is a single point of failure. You've got one process, everybody's like sending requests, shortening all sorts of URLs. Not a great way to structure it. So we really want to structure it so that you can spawn like maybe a worker per people requesting, sort of like how Phoenix works, and I'll mention that a little bit later. It's also a bottleneck for clients. It's a one access point, so that's a bit of a problem. But before I go into that, I do want to address the Elixir abstractions, tasks, and agents, since we've sort of gotten into this a little bit. So you've probably heard of tasks and agents. They're specific to Elixir, and they're basically abstractions that are built on top of GenServer, and they're sort of highly advertised, much more than GenServer or any of the other generic behaviors. So a task is basically you spawn a process, and it's just a long-running function. It finishes. There's no restarts or anything. It's just you're done. So it's very similar to in the object-oriented world. Maybe you want to run an expensive process. Maybe it's making a network call or save to a database or something like that. You just spawn a process off, do the work, and it comes back, you're done. Cool. You've probably seen the distributed map function. That's pretty common. So in the Elixir demos, at least, of you're mapping through an array and you spawn a process for each one and you wait for them all to come back. So those often use tasks. Also, you can block your current process using task, await, and stuff like that. And I'll show you just a quick demo from the docs, nothing fancy. And then on the other side, there's the agent, which is just for storing and retrieving state. It's not for long-running functions or anything like that. And to access that state, because it's running a different process, you pass an anonymous function, and you do whatever accessing or updating or reading you need to do. And it's not directly supervised. And like I said, the supervisors are for restarting workers and different strategies like that. So task example, like I said, very simple. Task async, pass in whatever work you need to do, and then task await blocks your current thread, or sorry, your current process, and until it comes back or times out or something. So there's a number of functions, await, yield, so there's some different ones. Start link is a little bit different. It actually links your process, and I'm not going to get into that a whole lot, but essentially you can monitor when the process dies, how to handle it. And it also means, so if you're on a process and you spawn some work and your parent process dies, that child process dies as well. And you can also put in the supervisor. But gist of it is it's for a long-running function. The agent example, I didn't make this up. This is just directly from the docs. So you'll see here there's a lot of anonymous functions, passing in, updating, and retrieving things. So start link, you'll see that pattern everywhere. You know, like I said, GenServers and agents and tasks and all that. And I personally am not really fond of this, just because the syntax is a little bit ugly. But aside from that, it just doesn't seem like it's very structured in terms of, you know, creating a process as you would an object in object-oriented programming, of having it encapsulate all of its functionality and sending messages to it. But it does work. There are plenty of good cases for it. So, jumping back to our other example, sort of done with that little aside. So the goal for this, to restructure this as a maintainable application, is to spawn a dedicated worker per client. So in this case, I want to expand this example in the demo at the end to have like a TCP connection, and you can update URLs, so anyone can just jump in there and do that. And each one would have a process associated with them. And we also want the workers to reference the same data without conflict, which is usually a nightmare in object-oriented programming. We also, it doesn't really matter to me to persist this data. You shouldn't jump to a database. It's certainly something I've been learning in the Erlang community. They think it's weird that everyone coming from Ruby is like, set up a database, throw it all in there. They're like, what?
Wait, so then they're not really using NetSub to state the database, they're just mainly using state and processes?
I mean, it would depend on the application, but they're not as hasty to jump to a relational database or something. Right. So we can pass an in-memory store to each worker that is essentially shared. And to do this, I want to use X, which is it's one of the tools and libraries of Erlang to store different, we're just going to store the shortened version and the URL itself. Nothing too fancy. But instead of walking through this, I want to just show you so we can just sort of take a breather, and I don't want to remember all of that. So this is how you would use it. So I've got a very simple test here, spawn 2 workers, and in this case, I actually insert directly into the X table my value. So this is the shortened representation URL, and we should be able to get from both of those workers the same state. Does that make sense? Take a look at it. So it's not really important how to use ETS right now. I can talk to you guys afterwards about how to use it. The primary focus is how to structure your applications with processes. So let me go ahead and show that to you, and we'll be able to see that test too. All right, so this is the test on the right, and then, nope, that's not it. All right, so over here, it should look pretty similar. So instead of our map that we pass in, we just pass a table reference to it, which in the test will set that up. So usually that would happen in a supervisor, or when you start your application, you create your table once, and then all of these things can reference it. So our state is the table. We don't care about any other configuration options. And as Duff suggested, we should probably move this down to here. So like I said, the the important thing is not the actual ets calls, but that you're using that in terms of the structure of it. So in this case, with ets, your first value in your tuple series is sort of like your primary key, essentially. And there's different types, but essentially this particular set says that there can't be a duplicate of that primary key. So you just have some lookups and stuff. Very similar. It's the exact same logic as just using ets. So any questions about this so far? Feel free. Okay, so I want to sort of show you this demonstration of putting all these things together. And, I can answer questions afterwards and stuff. I sort of went through this pretty quickly, so it may take a couple times to sort of wrap your head around it. I know I couldn't digest this all this quickly, so. So, let's see if I can get this demo up and working. So, if you would like to interact with this, you can connect to the Wi-Fi network, Christian's MacBook Pro. And like I said, it's going to have TCP connections into this, so you guys can all update the state at the same time. So hopefully, if I built this right, it should work together. And I'll explain how to use that. I also want to show you this observer tool because in terms of processes, it is fantastic. It's really cool. So we can actually see here the different processes that are named and such. So if you go to, let me just open up. So if you connect to the Wi-Fi network, Christian's MacBook Pro, and then if you do telnet, and that's the information. Let me jump over here. And I'll give you guys a minute to pull that up. Move this out. All right, so someone's already jumped in there and shortened spreedly.com. So you'll notice you can see different clients connecting here just in the log. So obviously someone figured out how to use it already. So you can just use like shorten. Is that big enough to see? You see that?
Yes.
Okay. And I should be able to, what was it shortened to? Spreedly. Oh, it didn't work. Okay, there we go. There you go. So you can sort of see that. But the cool thing, if you guys keep working on that, we can see the processes that were spawned here. This is really cool. So this solo process that I have designated here is just, it's using GenTCP. So I'm not using any extra frameworks, not Cowboy or Phoenix or Sugar or anything else. It's just waiting for connections and starting them off. And then these processes here are a connection process. And then each of them have a handler process. So if you do an incorrect command, it says server error. That basically, it will die and respawn it. So if you guys do /die, I just did like a bad arithmetic expression, 1 plus some string, so that it dies. And you'll see that the numbers here will actually change. And you can see, of course, in the log there. So if you watch these numbers, you should be able to see them change, and the supervisor actually restarts them. The other thing to note is the worker that I just showed you are these processes here. So this is where we passed in the ets table to each one of these, and they're all updating the same state. The other things I can actually see the state here built in with this tool. So these are shortened URLs. You can directly see that as they're updated.
So there's no process entry for the ets table itself. Should we consider that a process, or like how is that represented?
I think it is a process, but it's not in the application hierarchy. So this is only from the Elixir shortener application process. So the whole use application, start your initial supervisors and stuff, that will only appear here. Somewhere in here you can see the...
Is it in the kernel part of...
I don't know. So inetdb, I don't think that's it. I'm not sure, but it should be a separate process. So that's sort of how I structured it. I've got 2 supervisors, TCP, and then worker. And the other things you'll notice as these workers leave, the process is closed down. So one thing to note, if you ever used Phoenix, which you probably have, the way it works is it's using Cowboy underneath, and it has a connection for, it has a process for each connection and a process for each request. So thinking back to our first GenServer that we wrote, that was just one process. If you write that in Phoenix, all of your processes for all your requests are going to go through there. Terrible idea. So just be aware of that if you do use this in Phoenix. Does that make sense? So this is just an example. I have this code on GitHub, and I also want to recommend a couple of resources to you all. So Programming Erlang is a big fat book by Joe Armstrong. Goes through all sorts of introduction to Erlang. I would recommend, if you haven't touched Erlang, get familiar with it. It can be a little bit hairy with the syntax and stuff, but I would definitely recommend jumping into that. He's got all sorts of things on OTP, GenServers, GenTCP, all that sort of thing. The other one that's great, Elixir in Action. I know, Brian, you mentioned it a while ago. It does a really good job. It actually walks through in Elixir building like a to-do manager with workers and database and all that stuff without having, I think, any third-party dependencies. So that one is specifically Elixir. You don't have to do any Erlang for that. My favorite is actually the middle one by Francesco Cesari and Steve Vanoski. It's like I would say, sort of the manual on OTP. It's got like everything you need to know in there. I listened to the Erlang Factory talk that he gave, and he talks about the last 4 chapters, and he actually talks about node strategies of, very much, high speaking of, entry-level nodes, business logic nodes, so very large-scale applications. So this is sort of, at least for me, it was sort of like a whole, mind-bending thing of a totally different way to understand how to build applications. But it's pretty cool, I think. So this is URL for the code. You can go ahead and check that out. And I'm happy to answer any questions.
I had a question about, I think I missed it, in the part where you added ets to the equation. I missed where you also made it a worker setup as well.
You mean the
you just created a new
I just created
two of the shorteners.
Right.
Okay.
Obviously, if you're writing tests, this is really lame. You should write more tests than this, but just as an example.
But all that change within the shortener itself was you were using ets, the ets table that was passed in.
Correct. So that was actually in the demo. So when you were using it, that was this actual worker module. So
It's pretty interesting how they pass the result of setup into each test. I'm still not used to that.
yeah, it is a little bit weird. I always like to have to decide, do I put it up here or not?
I'm still not sure when making a Phoenix app how to decide when to go and create another process for something, or
Yeah, it's a good question.
I don't know when to.
I started using it. I ended up rolling back on the feature, but I used it for a undo manager. So essentially, you had to represent some sort of JSON or something, but it didn't matter that it was persistent. So I ended up using ets, and I'm sure I'm a total beginner at this in terms of when to use them and all the other features of state management and all that. That was the usage I had. But like I said, you got to be very careful of, you got all these processes all referencing one. So just to be aware of that. And actually, it's pretty interesting. If you open up Observer on a Phoenix project, you can see Ecto has quite a bit of workers and connection pools and all that. So it's pretty neat.
What is the name of the tool you were talking about? Is that called Observer?
It is called Observer. So you can reference it in your code with just an atom observer dot whatever. In this case, you can just actually in the REPL you can just say observer start, and it'll just launch up that application. So I think it's pretty cool. It's built in. Yeah.
If your processes go down, is there any way to get their state back, or is that where something like ets comes in to try to persist that a little bit better?
Supervisors, actually.
Okay.
Yes. So you can either dynamically start children essentially of the supervisor with your processes and give it a state that lasts across all of them, or you could keep a handle on the process just yourself and do the management of. It goes down, I have to keep this connection, TCP connection or whatever, like the same sort of thing in there if you want to take a look at something.
Cool.
So, what use cases in Elixir do the task and agent not cover that you would then go direct to a GenServer and use GenServer for?
When you want both. So when you want sort of an expensive operation and state, I think is the best use case.
Do you find that you use GenServer itself a lot, or in Elixir do you find that you're using the abstractions of task and agent more?
I personally prefer GenServer, but that's just personal preference. I'm sure there's other reasons that I don't know about. So, and actually, it used to be that you had to drop down to Erlang to use GenServer at all, but they added the abstraction recently.
Mhm.
Yes.
Well, are you still you mentioned Erlang. Do you find it still useful to stay in Elixir, or are you doing more just in straight Erlang now?
No, but the thing is, all of the documentation and information and talks are all in Erlang. So I just meant in terms of being familiar with it, being able to read it. Sure.
Well, no, I'm sort of confused about both, but I do find the Elixir Erlang syntax to be quite confusing.
Yeah, it is challenging.
I think that could get kind of complex when you have this process that's sitting here, and you mentioned all the Phoenix processes hitting it. How do you resolve that? I mean, you've got to put a bunch of workers in front with Poolboy or something, like to manage the connection, the pool of workers. Like, it just seems like a complex thing to manage.
There's a number of ways you could do it. If it's just temporary, throw a task on it. You just have a long-running expensive thing. You can do it in that process, in the Phoenix controller or whatever, spawn the process. So now it's just sitting off of that one process. It's not all channeling into one. Or you can do pooling. That's what Ecto does. So the nice thing about Ecto, if you ever used it, you just make function calls into it, and you just get back whatever. And you don't even think about there's any concurrency under there, but it's got its whole network of processes that it uses. And it's definitely a challenge to decide when to use a process versus just a module. And I still don't have any great answers for when that line is. Any questions? All right.
Cool.
Well,
Thank
thank you
you.
very much.